In previous lessons, we've learned a bit about the human memory system, the differences between episodic and semantic memory, the process of consolidation, synaptic plasticity, etc. In this lesson, then, we'll try to tie together these concepts and see what they mean for effective study strategies. Knowing how the brain learns and remembers has implications for designing good study strategies. So in this first setup lesson, I'm going to go quickly through these slides because a lot of this information we've covered earlier. Now we're familiar with the kinds of memory systems in computer. We have the RAM system. It's a short-term, fast access memory system with limited storage capacity. We have the hard drive. It's a long-term storage system, slower access to that information, but much larger storage capacity. And so computers have these two kinds of memory. And if we think about education, then the idea is to get information stored into our long-term memory system and store it well so that we have quick and reliable access to that information. Now, brains have the equivalent of the fast, limited capacity memory system, the working memory system, and also the slower, larger capacity memory system called long-term memory. And whatever's in working memory has the potential to be stored in the long-term memory system. The medial temporal lobe and the underlying tissue, structure called the hippocampus, is critical in transforming a short-term memory into the long-term memory. And this process called consolidation writes the new information into the long-term memory system so that its later retrieval is dependent on the quality of consolidation. We'll say more about that in a moment. Now, the hippocampus is an important structure because it is a site of convergence of lots of information in the brain. So whatever's happening to us, what we're seeing and hearing and such, converges in the hippocampus, and a memory trace will be made, linking all of those different sensory and perceptual aspects of the event together. So the hippocampus makes a strong memory trace of a learning episode. However, the cortical memory trace is weaker at this early stage. So we have a strong memory trace of a learning episode in the hippocampus, but a weaker memory trace in those parts of the cortex that were processing the learning episode. So consolidation is not simply storing the information in a different place. Rather, the memory is transformed. It's reorganized across different brain areas, the hippocampus and the cortex. And this reorganization is necessary as the new information is being integrated with previously stored memories, what we're going to call semantic memory, and they are stored in cortical networks. In the lesson on HM, we use this diagram to illustrate the situation. Early on, we have a strong memory trace in the hippocampus, a weak memory trace in the cortex. After consolidation, the cortical memory trace has been strengthened. So metaphorically, the hippocampus teaches the cortex to make hippocampal independent memories. The stronger memory trace involves the cortical regions that were originally activated by the experience. In the lesson using the amoeba as an example, before consolidation we have a weak memory trace of what we learned about amoeba. After consolidation a stronger memory trace. And when the memory trace is strong, then frontal cortex retrieval systems can activate those memories without a hippocampus even. We saw this with neurological patients like HM who didn't have a hippocampus but could retrieve semantic information. So consolidation has the effect of strengthening the cortical memory trace so that normal cues are sufficient to retrieve the memory, and you don't need the hippocampal system anymore. Frontal cortex retrieval systems can activate the memories, and then the memory loads up into the working memory system. At the level of synapses, early on we have a strong memory trace in the hippocampus, but weak synapses in the cortical neurons that processed the learning episode. After consolidation, those cortical synapses are strengthened by an LTP phenomenon. So consolidation integrates new information into the semantic memory system. Every learning episode happens as an episodic learning event. And now we may forget the circumstances of learning, but if consolidation has happened successfully, we will be storing new information into our semantic memory system. And in fact, we can just strengthen information that's already there. So semantic memory we can think of as our stored knowledge of the world, and an education then is integrating new concepts into a web of knowledge. the semantic memory system. And we drew that web sort of down here, like concepts are linked together in meaningful ways. So to be well educated means we have stronger links, and that leads to faster access of the information and slower rates of forgetting. So we want to be well educated, have lots of concepts that are strongly linked together, as opposed to minimally educated, where we don't know many things and those concepts are not strongly integrated. Now, brains differ from computers in that the quick and reliable access to a long-term memory may require multiple consolidation events. That is, memories stored in brains can be strong or weak or somewhere in between, and this is unlike a computer. In a computer, bits of information stored on the hard drive are stored with the same, in a sense, quality as any other bit. So in other words, the strength of storage of one bit of information is the same strength of storage as every other bit of information on the hard drive. And this is a significant difference in the way computers and brains operate. For brains, the writing process, the storage process is a biological process. And so the more consolidation events happen, the more biology goes on there, the stronger you can store the information into the long-term memory system. And so from the point of view of study strategies, we want to be mindful that to learn something well may require multiple consolidation events. And this raises the question, well, what are these consolidation events and when do they happen? Well, scientists have learned that when we learn something new, right after learning, sometimes the hippocampus sort of replays that information. That may be helping the cortex strengthen the memory trace in the cortex. In addition, during sleep, there seems to be significant memory processing going on. Again, the idea is that's part of the consolidation process. So sleep helps to strengthen cortical memory traces of recently learned information. So we have to allow our brain to do its biology to have well-stored memories.